Okay, good morning, everyone. Okay, just sound check first. Can everyone hear me loud and clear? Okay, thank you very much. Okay, so with that, right, let's start the talk for this session. Okay, yeah, thank you for attending this talk and welcome to NUS Open House 2022. I'm Brian, a senior lecturer and consultant with the NUS Institute of System Science. So for today, right, I'll be sharing with you on the topic of AI governance, which is of increasing interest in the field of AI. Okay, at any time during my talk, right, if you have any questions, you can just enter it into the Q&A. Then after the end of the session, right, after the end of my talk, then I'll try to answer all your questions, okay? Okay, with that, right, let me give an introduction to AI first to put everybody on the same page. Okay, basically, AI itself is a very complex field, and there's a lot of branches under AI. So, like for example, the computer vision. So for computer vision, right, is usually widely used in the area of, like, for example, images and video, and is used in the application of such as the face recognition, object recognition, scene recognition, and also like movement detection within videos. Then for speech recognition and processing, so for speech recognition and processing, usually is used for like speech to text transcription. It can also be used for like text to speech synthesis. So for speech to text transcription, right, one of the use cases would be things like the media transcription or the voice transcription. Yeah. Then next, we have the natural language processing. For natural language processing, it deals a lot with text and word stuff. So like, for example, document summarization. Then in chatbot, right, you see a lot of like Q&A and answering of questions. So basically the analysis of the text itself, right, a lot of times uses the natural language processing. Then you also see another branch of AI is the robotic system. So for robotic system, right, very often is used for automation. Okay. Then for planning and optimization, you see it quite often in, like, for example, route optimization. It means traveling from one point to another point, how you actually optimize the route to have the shortest route or the faster route. It's also used in things like timetable scheduling. Then for evolutionary algorithm, right, another branch of AI, evolutionary algorithm is also very often used in optimization applications. Then we have the artificial emotional intelligence. So for the artificial emotional intelligence, right, what one tries to do is to mimic human emotions and then input these emotions into the computers or robots itself. Yeah, then we have many others such as like knowledge representation, reasoning system, learning algorithms, so on and so forth. Okay, so you may have heard a lot about AI itself. Like, for example, a lot of good things about AI, the AI breakthroughs in the recent years. So over here, right, as you can see, one of the articles actually state that the Chinese AI, right, beats doctor in diagnosing brain tumor. So a Chinese AI system actually diagnoses brain tumors and other conditions more accurately and even faster than a team of top Chinese physicians. Okay. Yeah. So that's why there's like so much hype about AI in recent times. Then in another article, it states that Microsoft speech recognition is now as good as a human transcriber. The system just achieved a 5.1 error rate, which is on par with human. So that means the performance of the AI itself is actually as good as a human. Then even locally, right, we are actually tapping on AI to better COVID-19. We are using AI in areas such as smart clinical chat assistants, to help us in this COVID-19 situation to answer like questions, the common questions, like for example, that citizens has on the COVID-19. And also AI itself, right, has also been used a lot in temperature sensing or temperature sensors, where there's image recognitions within the AI itself. Okay, so these are the few breakthroughs that you can actually see in the recent years of AI. And this is actually made possible, right, because of things like faster and cheaper computing power, larger computing storage capacity, and also the advanced algorithm research of AI. Okay, on top of this application, you can also see AI in our daily life. Like for example, the Apple Watch, it has the Siri inside, which acts as a personal assistant. Then for Google Map itself, right, it helps a person to navigate from point A to point B. And I myself use Google Map very often. I rely on Google Map very often to go to new places. Then also on the face recognition system. So on the face recognition system, right, you may see this where entering an office or a building. So they actually use the face recognition system to allow entry into a building, like for example, workers or staff within a company entering into the building. Okay, and this is getting more and more common, using face recognition for entry rather than pass access. Okay, so on top of the examples that I've shown you just now, right, AI can also be applied and have been applied in the various domains as seen over here. Okay, so AI is actually applied in almost all the domains. Like for example, for the retail side, right, in the retail side, very common, you see personalized recommendation engines. Like for example, if you are buying a pair of shoes, right, then the recommendation engine may actually recommend you, like what are the other clothings or what are the other pair of shoes that you may like. Then in manufacturing itself, right, you will see a lot of robotic system. Okay. Then for security itself, computer vision has very often been used, like for example, in anomalies detection. Then in banking and finance, also anomalies detection, and banking and finance also use a lot of chatbots. For automotive, right, self-driving vehicles, logistic in this sense will be like route planning and optimization, how to deliver a set of goods, right, or a few items at different places in the most optimized manner. Then social and lifestyle would be a lot like personal assistants or smart homes. Some of you may have like smart home devices in your house. Then also for healthcare will be things like the medical imaging using computer vision. Then in F&B, you may see service robots or recommendation engines also. And the uses of AI, right, it's actually span from like the government sector to the SMEs, to the consumers, the organizations, and also the MNCs. So a lot of times, actually, almost everyone is a user of AI itself. Then with all the success and hype around AI, right, you will intuitively you will know that the AI adoption trend has been increasing. And from all this market research, right, as can be seen on the top left, the enterprise adoption of AI, right, has been increasing over the years and is forecast to increase further to in 2025. Okay. Then the revenues from AI market worldwide has also been increasing over the years. Yeah. And actually it has been increasing sharply. Then even in the wake of COVID-19, right, where the economy is not so good, companies has also speed up the AI rollout in the wake of COVID-19. Yeah. Then AI adoption skyrocket over the last 18 months. So what you have heard of AI are all the good, right? All the hype and good about AI. So is AI all good and no bad? But what if AI gone wrong? Okay, what if AI gone wrong? Then in recent times, right, there's report about 2 killed in driverless Tesla car crash in the New York Times. Yeah, so this is a case of AI gone wrong. Then even locally, right, there's news article about driverless car hit lorry during test drive. Yeah, so these are examples of AI gone wrong. So when something go wrong, right, who's to blame? And in this article, it actually states that software anomalies to blame for driverless car accident. A mixture of software glitches, which is extremely rare, affected how the car responded to other vehicles. So that brings us to the other side of AI, the governance aspect of AI itself. Yeah. So when AI gone wrong, right? In terms of accountability, who should be accountable for? So the fault could be due to software issue. The fault could be due to software issue, or it could be due to hardware issue, or it could be due to the design issue itself, or the structural issue, or software by itself could be functioning properly. Then the hardware by itself could also be functioning properly. But when they are put together, right, then there's compatibility issue. So it could also be a case of the compatibility issue. And the AI itself, right, everything could be compatible and it could be working in the testing environment. But once it's put the real environment, right, when the system has to encounter several adverse environmental condition, then it could be due to the environmental issue that caused the AI to go wrong. Yeah, but in any case, right, when something go wrong, in terms of the penalty and the punishment, right, one cannot penalize or punish the software itself and cannot punish the hardware itself. When something goes wrong, right, someone has to be accountable for, and who will take the responsibility. So is it the management of the company who actually sets the direction and takes charge of the company, and the one that actually endorsed the AI project itself? Or is it the project manager, because the project manager is the one that oversees the whole project? Or is it the system architect, because he's the one that architect the overall system? Or is it the AI scientist that code and design the algorithm? Or is it the software engineer that code and program the software? Or is it the quality assurance engineer, because they are the one that controls the quality of the system itself? Or should it be the safety engineer, because the safety engineer is supposed to be in charge of the overall safety? Or is it the mechanical engineer, that is in charge of all the mechanics of the AI system itself. Yeah, so on and so forth. So is this a straightforward answer in terms of who should take the responsibility? And also how to trace back to the issue and under what reasonable circumstances is the fault acceptable? So these are actually still open questions and something to think about. It is not so straightforward. Okay, so in terms of AI governance, right, what happens if there are no penalties on any AI system error? So think about it. What happens if AI, right, is free to make any error, and is free to go wrong? What will happen? Then what will happen if there's extremely strict regulations and heavy penalties on AI system error? What will result from all this? Okay. So basically, right, if there are no penalties on any AI system error, then without due care and due diligence, the AI system may potentially endanger life, impact businesses, disrupt society, and create fear, etc. There will be a lot of like severe consequence. Then what happens if there are extremely strict regulations? Basically, it will actually kill the innovation and advancement of AI system. Nobody will dare to innovate for the fear of being punished. So the question and the key thing is, how do we actually encourage innovation yet safeguarding the interests and safety of humans? So it's actually a balancing act between encouraging innovation and also like safeguarding the interests and the safety of humans. So this is actually something to think about. There's no straightforward answer to this also. Okay, with all this governance aspect gaining attention, right? There has been initiative at the, for example, at the specific industry level, this is the finance industry, or more at a broad-based level. Yeah, so this is sector agnostic. So the MAS, right, has come up with the principles to promote fairness, ethics, accountability, and transparency in the use of AI and data analytics in Singapore financial sector. So this is with regards to the financial sector. Then the IMDA has come up with a modern AI governance framework. And this is across, and this is applicable across all sectors, which means this is sector agnostic. So on top of the government initiative, like locally, right, private companies, usually the larger companies, also come up with initiatives. So there's this partnership on AI, which is founded by Amazon, Apple, DeepMind, Facebook. So Facebook is now called Meta. Then Google, IBM, and Microsoft. So this partnership on AI, right, is to make sure that AI is developed and used in a safe, ethical, and transparent manner. Okay. So next we will go on to the AI model building stage and how AI governance, right, is related to each of the AI model building stage. Okay, so for AI model building stage, we see that there's the business objectives and problem statement identification during the start. Then after that, it will be followed by the data collection, exploration, and preparation. Then also on the model development and testing, the model deployment, and model monitoring and maintenance. So how does AI governance relate to each of these stages? Okay, it does not mean that AI governance is linked to only one stage, but is actually relevant across all stages, as we can see on the next slide. Okay, so for AI project, right, one needs to start off with the business objectives and the problem statement identification. that is at the stage where you need to decide whether to adopt AI. So basically, right, the problem itself or the problem statement itself, whether firstly it can be solved by AI, and whether using AI to solve is the best solution, or there's other simpler solutions that can be adopted. And if the decision is to adopt AI, right, then the company needs to assess whether the company has the appropriate resources to adopt AI. Then next, after the decision to adopt AI, right, then next we'll move on to the data collection, exploration, and the preparation stage. Okay, so at that stage, right, before the data collection, so these are the things that you need to think about how to collect the data, from who to collect the data, and one must have the consent to collect the data, whether consent has been given by the subjects themselves to collect data, yeah, and whether the company has obtained the consent from this individual. Then after the data collection, it will be the model development and testing stage. Okay, so at the model development and testing stage, right, then we'll think about the transparency in model building, which I'll elaborate a bit further in the later slides. After the model is being developed, then we'll talk about the model development. Basically, in model development, we'll consider the ethics in deployment. Okay, in terms of model deployment, yeah. So in terms of model deployment, right, we'll talk about ethics in deployment and also the human intervention in the deployment itself. So this I will also share with you in more details in the later slides. Then last but not least is on the model monitoring and maintenance. Okay, so basically we'll need to decide whether the model is outdated or still relevant given the change in time and circumstances, or whether the model can self-learn and update itself also. Like for example, in some chatbot system, right, the model can actually learn and update itself in terms of the database. Okay, we are not going to cover all that I have mentioned just now, but in particular, we will focus in the context of and in more detail of these few points, these few areas. Okay, these are some of the areas that we discuss in more detail. Firstly, the ethical data collection for model building, ensuring fairness and eliminating bias in model, and also intervention in model deployment. Okay, so as you know, right, data itself is very important. Like data is one of the most important factor in AI model development. Without data itself, there's nothing much we can do. We cannot create an AI model. So data and the data collection stage is actually one of the important stage in AI model development. So in terms of ethical data collection consideration for model building, right? Then what do we need to consider when we are performing data collection? So here are some of the consideration factors. Before data collection, right, we need to have the consent of the subjects. So basically the subjects that provide the data must give us or give the company that's collecting the data the consent. And these subjects, right, need to know what data is being collected, like exactly what data is being collected from them. And also, the subjects should have the ability to opt in and opt out of the data collection process at any point in time. Then they must be guaranteed the trust that the data is to be deleted after some time, probably when it's not in use. Then also the usage of the data itself, right, is for a specific purpose. That means the purpose that is stated during the data collection and will benefit the general public or users. That means they themselves. And also data subjects may want to know how the data is being used, and who has authorized access to this data. So if they request to know, right, then the organization that collect the data itself may need to explain the process. Okay? So that is on the ethical data collection consideration. So next, look at what is bias in the AI model. So basically, right, bias in AI, right, happens when the model itself or the algorithm itself discriminate against a certain group. So it produces undesirable outcomes and does not provide a fair assessment and judgment towards a certain group, right? That means it's biased towards a certain group. So bias in AI, right, may be detected at the output stage. However, it may not always be apparent unless enough cases were presented and analysis being made. Yeah. So if, like, for example, if there's only 1 or 2 cases, it may not be apparent. However, if for 1,000 cases and the result always biased against a certain group, then it's going to be obvious. Okay, then the next question will be, is bias caused at the output stage? Because since it's only seen at the output stage, or is caused at a much earlier stage? So that we'll look into it. Okay, over here, right, this is an article which states that an Asian man is applying for his passport through a robotic system, and he got an error. The error is that the photo you want to upload does not meet our criteria because the subject eyes are closed. So in this case, right, it's something to think about. What could have gone wrong in this case? Could it be a case of not sufficient and not representative training data? Yeah, so this is something to think about. Okay, in another case given here, okay, in this example, right, Amazon actually scrapped the AI recruiting tool that showed bias against women. Okay, the experimental AI tool was not rating candidates for software developer jobs and other technical posts in a gender-neutral way. Then the AI model were trained by observing patterns in resumes submitted to the company over a 10-year period. But over this 10-year period, right, most of the resumes actually came from men. Okay, so in this Reuters news, right, it actually states that the Amazon experimental recruiting engine followed the same pattern, and it learned to penalize resume, including the word woman, until the company discovered the problem. Yeah, so if you feed in training data that is biased in a way, then the decision made by the AI model, right, will also be biased in a way. Then as you can see from these statistics, right, the employees in technical roles in these companies, the male ratio, the population of male is actually much larger than the population of female. Okay. So this is another case of bias in AI. And you can see that although the bias happens at the output stage, but is very much affected by the training data itself. So bias, though seen at the output stage, right, it can be due to much earlier stage. Like, for example, during the data collection stage, where data collected may not be representative of the population and lacks diversity. Okay, so basically, in terms of bias, there can be a few type of bias, like, for example, the human bias. So human bias occurs when decision makers and stakeholders influence data collection during problem framing stage. That's why it will create a bias. Then there's also sampling bias. basically is due to data collected not representative of the demographics or the population, and it lacks diversity. Then precedent bias, model is trained on precedent data or formal method of process itself. Okay, so in the case of the one that you have seen on the Amazon example just now, right? The model is trained on precedent data, the past 10 years data, mostly the resume actually comes from men. So it could be a case of precedent bias. Then technical bias is usually due to the equipment used to collect the data and the inherent setting at the data collection stage. And usually it occurs in the audio equipment or visual equipment itself. Okay, how do we ensure data integrity to minimize bias? Okay, so here are some points to help ensure data integrity to minimize bias. Okay, so first, right, in terms of accuracy, one needs to ensure that data collected is accurate and there are no noise, no calibration mistakes, and participants of data collection have to understand the questions and response accurately. Because if they do not understand the question and they fill in rubbish, right, then it's going to be garbage in, garbage out. Okay. Then another factor will be the completeness. Make sure that the data collected is representative of the population and is comprehensive. Data is diverse and not skewed. Then the validity. Ensure that the data collected is up to date and not dated. Data is still relevant in today's context and suits the context of deployment. Yeah, and especially like, for example, in recent time, right, due to the COVID situation, many situations would have changed. Like, for example, the travel volume, the sales volume, the online revenue, all this. So all this data has to be updated if you are doing a prediction model, instead of like using instead of using like past 10 years data, I would think that maybe the past 3 years data would be more relevant. And also in terms of data source, ensure that the data is from a trusted source. And when possible, right, try to perform own data collection. And when the data is from external source, make sure that there's expertise within the company to check the data. Okay, then when there's bias in the data, right, are we able to totally remove bias in AI? Okay, so is it easy to fix bias in AI? If we find a problem in AI, can we fix it easily? Then consider the resources required to collect data from a large diverse group. And actually, does the company has the resource to collect such diverse set of data? Then if sampling needs to be done, right, is there expertise within the company to do sampling? Then could fairness and bias be subjective? So like, for example, if for AI job allocation optimization system, right, basically different job scope with different hours and with different level of difficulties, to different people, the job scope level may be, in terms of difficulties, right, may actually be subjective. So the AI job allocation system or the optimization system, no matter what is being crunched out, right, there'll be certain group of people that think that, oh, it's not fair, right? Then also, how do we quantitatively measure fairness or bias? Yeah. So if there's absolute measure such as like the number of hours, then I think it's quite apparent whether who do more hours or who do less hours, like in a job allocation. But when there's no absolute measure, right, then it can actually sometimes be quite subjective, like in terms of like what I mentioned just now, in terms of a job level difficulty. Yep. So this is something to think about. Can we actually totally remove bias in AI system itself? Okay, with that, right, I'll move on to trust and transparency in AI model. When like human have trust in AI model, and why is it important? So basically, right, human will have trust in AI model when they know what is the decision taken by the model at each stage. So like, for example, between different path A and path B, path C, path D, right? The AI will choose path B, and the human actually know that the AI chooses path B. Then why did it make the decision? Like, why among all the paths, it choose path B? Then what is the confidence of the decision made? Like, for example, the AI is 90% confident, 99% confident, or it's just like 60% confident. It's like not very confident. And how to tweak or correct the decision if it's not correct. Yeah. If the AI give a result that's wrong, right? How the decision can be corrected in the next time. Okay. Then can the same model and same results be obtained the next time given similar situation? So if the model is good, right, and you want it to be repeatable, given the similar situation next time, can the same model and also the same good results be achieved? And last but not least is the model auditable. So can we actually open up the model and the algorithm to check the internal working mechanism? Are the source code given? So these are some of the considerations we look into in terms of trust and transparency in AI model. Okay, so you have seen, right, one of the factors that build trust in AI is explainability. So we'll look into explainable AI. A more understandable and comprehensive model, right, will intuitively gain more trust and be of better use to human. Then some of the comprehensible models are being presented here. So like, for example, we have the rule-based system. So it actually states that if antecedents, then the consequence. So that means if a certain conditions are being met, right, then what is the classification or what is the outcome? And this is like rule-based, if-then rules. So in terms of this, a human can actually interpret. Then over here is also show decision tree. Decision tree is also quite comprehensible in the sense that if based on a certain condition, right, if it's true, then you take the left-hand side, then if it's false, then you take the right-hand side in this case. Then over here, if this condition is yes, then it goes left. If not, it goes right. So this is something like a flow chart, yeah, which can be interpreted as rules by the human. Okay, in terms of black box model, right? In terms of black box model, you see here we have the neural network where we have the input, where we know the input and the output, but the internal working mechanism is not known. So we call it the black box model. Then over here, we also have the deep learning model where we know the input and the output, but the internal working mechanism, the exact internal working mechanism in terms of whether is it easily understandable by human is also not exactly known. Yeah, so it's quite hard to comprehend this model. So they are called the black box model. Okay, this shows an illustration of the limitations of black box model and why there is less trust in black box model. Okay, basically, right, you put in the training data, then go through a learning process. So you have a learned function or a learned model. Then you put in, like, for example, a testing set, a testing image. You go in, then it gives you an output. The output is just, this is a cat. This is the final output with confidence of like maybe 0.93, which is 93% confidence. So the user, right, will be scratching his head and asking, why do you do that? And why not something else? And when do you succeed? And when do you fail? And when can I trust you? And how do I correct an error? Okay. Then this is what one hope to achieve in the future of AI model, where we have more explainable model and opening up like the black box model. So what we hope to achieve in the future is that we feed in the training data as usual, you will learn have a learn model. Then this learn model is not a black box model, but an explainable model. Then you feed in the training data, testing data, right? Then you have a user here that is actually able to interact with the interface itself. And this is an explainable interface. Like the user will actually know that, oh, this is a cat because it has furs and whiskers and claws. And it also has these features. Yeah, so the user will be able to understand why and why not, and know when the AI will fail and know when the AI will succeed. And that's when they know when to trust them and know why the AI system actually has an error. Yeah, this is the future of AI model that we hope to achieve. Okay, so just now what I've went through a lot is on the model itself, transparency in model. But apart from trying to open up the model to understand it, right, what are the other efforts that can be achieved to gain better transparency? Okay, so the Financial Conduct Authorities of UK has come up with a framework, right, that on top of model transparency, that includes also the process transparency, So they call it this framework the AI transparency with the model transparency. So the model transparency will include the model code and the other information about the input-output relationship. Okay. Now on top of that, they have this process transparency, which relates to the development-related information and also the use-related information. Okay, we shall see in this slide. So for development-related information examples, right, it's like how a decision is made at the adoption of AI. Like what data is being collected, the data source, the consent given, decision about the selection of data being used in the model development. So there should be transparency in all this. And like, for example, when data is being collected, right, usually it tends to collect a lot of attributes or a lot of features, but not all of these features is required in the modeling of the AI. A subset of these features may be used in the AI development. So in terms of the selection of these features, right, for the model development, is there like what kind of decision or what kind of thought process has been made? Yeah, so whether is it being documented now and whether there is transparency during the process. Then the decision choice of the algorithm that is being used is like, because for a given set of problem, right, basically there's a lot of different AI algorithms that can be used. So among these AI algorithms, why is one algorithm being chosen? Yeah, why is this algorithm being chosen? Is it because it's better than another algorithm in terms of accuracy or lower in terms of error? Yeah, so this has to be documented down, and there should be transparency in the process of selection of the algorithm itself. Then how many iterations are being run or how many trials are being done during the training and the testing stage of the AI model development. Whether K-force validation are being done, or is there limited trials being done, or are there enough runs being done, like thousands, to ensure the robustness of the system itself. Then on top of development-related information, right, there's also the use-related information in terms of the process transparency. So the use-related information will be things like where is the AI deployed, the environment that the AI is suitable to be used in, and who are the suitable users. Okay. So next, I'll move on to another topic in terms of AI governance, which I've also mentioned earlier, is in terms of the human intervention in deployment. So basically, right, can AI be totally autonomous, semi-autonomous, or still require human intervention? So let us consider these three types of human intervention. Basically, human in the loop, human over the loop, and human out of the loop. So for human in the loop, right, basically human is actively involved in the process. Usually human will review the output and makes the final decision. And it actually has the full control, and AI is just a complement or to provide suggestions to human actions or provide alerts to human. Yeah, as humans sometimes can be like quite tired and due to fatigue may make an error. Yeah, so human in the loop, right, is like, for example, some of the example of human in the loop AI process would be like, for example, in medical diagnosis, where AI may suggest certain diagnosis, then the human doctor, right, have to review the diagnosis of the AI, and the doctor himself or herself have to eventually make the final diagnosis and decide what treatment is best for the patient. Then another example of human in the loop would be like, for example, the broadcast speech-to-text transcription. The human transcriber has to review the text that's transcribed by the machine itself before it can be presented to the general public. It can be added to the general public. Then the second one will be human over the loop. Okay, human over the loop is when human oversees the AI function and can choose to or override when required, such as some applications are such as the route optimization, where a delivery man will be presented with a few options by the AI, like for example, the shortest path, faster path, or a route without ERP, so on and so forth. So the rider can actually choose and override at any time. Then for human out of the loop, right? For human out of the loop, basically, right, for this, right, human is not involved, is totally not involved at all. And the AI system itself actually funds the customer or the user itself. So things like, for example, the recommendation engines and the chatbots, where humans do not evaluate the output of the AI before presenting it to the customer. Okay, so there's no need to evaluate the output. Okay, so for these three types of human intervention, right? For these three types of human intervention, consider these three buttons and which button to press and in which situation. What are the consideration to the extent of human intervention in AI? So for human in the loop, right? So one would probably think that it's more for mission critical tasks. A wrong action by the AI may cause great harm or severe consequence, or it may be a life and death matter, okay? So that is when human in the loop would be appropriate, yeah, for mission critical tasks. So things like, for example, medical diagnosis, okay? Because medical diagnosis is a life and death matter, so I think it's important to have human in the loop. Then for human out of the loop, right? For human out of the loop, then one would think that is for non-mission critical tasks, such as question and answering FAQ, or if the output is just recommendation. So like, for example, recommendation to user, like shoppers buying clothing, like, or movie recommendation, then human out of the loop would be appropriate. And also for such tasks, right, there's usually a large number of users and it may not be feasible for the human to review each and every recommendation by the AI machine itself. Yeah, so it's best to have human out of the loop. Then for human over the loop, right, so it'll be for those in-between cases where the situation may change and require actions or feedback from human. Okay, so that's on human intervention in deployment, which I've just discussed. So next we'll move on to the topic of the future of AI deployment. As we look into the future of AI deployment, right? So I'd like to share with you the famous 3 laws of robotics from the science fiction short story by Isaac Asimov. So this is something to think about actually, and this is quite interesting. So the 3 laws of robotics. The first law is that a robot may not injure a human being or through inaction allow a human being to come to harm. Okay, then the second law is a robot must obey the orders given it by human beings, except where such orders would conflict with the first law. Then the third law is a robot must protect its own existence as long as such protection does not conflict with the first or second law. Okay, so these are the three laws of robotics by the fiction short story by Isaac Asimov. It's quite famous, and I think it's quite interesting. So something to think about is like, to what extent can this be achieved, and how far are we actually from this goal? Okay, then last but not least, some food for thoughts on AI ethics in terms of deployment and whether is it straightforward or not. Okay, on the left-hand side, right, you see the trolley problem. So this is the famous trolley problem in the ethics field. Okay, basically it states that a scenario in which a trolley is going to collide with and kill 5 people down the track. But a bystander can intervene and divert the vehicle to kill just one person on a different track. Yeah, by pulling this handlebar. So the bystander can actually intervene. Okay, what would you do if you are the bystander? Is it a straightforward answer? Okay, this trolley problem, right, has also been modified. And actually there's quite a few versions. And this is one version that has been modified to be used in the AI robotics itself, autonomous vehicle. So over here, right, the situation is such that the autonomous vehicle, right, is coming to is traveling, and it cannot brake in time, and it's coming to a zebra crossing. So it cannot brake in time, right? And there's a baby and an elderly crossing the road. So which path should it actually take? Yeah, so bearing in mind that it cannot stop in time. So which path should it take? Should it take path A, where there's a baby, or path B, where there's an elderly? Yeah, so potentially, the path that it takes, it will potentially injure the baby or the elderly. Okay. So what would you do if you are the bystander, or which route should the autonomous car take? Is it a straightforward decision? And can actually human decide on this scenario? And is there actually a correct choice? Yeah, actually there's no correct choice, and it has been very much debate in the ethics field. So if human cannot decide, right, then how can actually AI decide for itself, right? Yeah, so this is some food for thought and some questions that you may like to think more about. Okay, with that, right, I will end my AI governance talk here. Thank you for attending. So if you are interested to find out more about this topic, or like to find out more basically in this area, right, do feel free to email me. Okay. Okay, you may also like to join us in NUS-ISS also. We have also many other courses in the area of AI, in the area of data science. So for more information, you may visit our website, and you may contact any of our colleagues to find out more. Okay, currently, our Master of Technology program application is also open. So for more information, right, you may visit our website or email us at this email address. Yeah, you may scan the QR code to visit our website. And for more information about us, right, do visit us at these various platforms to get more information. Yeah. Okay. Also, kindly help us do a short post-event survey so that we may improve for future events. Now you can scan the QR code or go to this link to do the short survey. Yeah. So before I close the session, right? Let me look at the Q&A. Okay, there's a question on what courses can I take in ISS to start for AI? Okay, basically, right? Yeah. Okay, my colleague Yap Ming has given the link of the courses we offered on the ISS in ISS, right? So basically, you can go to the website itself, our website. Then you'll be able to find under the data science. So under the AI and data science. So basically for AI, right? You can go to the program specific for AI, and actually we have a lot of courses there from the fundamentals, foundation courses to the advanced courses. Yeah, so you can take a look at from the course website. And for any questions you have pertaining to the course itself, for the course itself, right, there'll also be information within each of the specific course where you can actually contact the course manager to find out more, like for example, what is the topic of the course, what is the learning outcome, what is the objective of the course itself. Yeah. Okay, yeah, thanks, Yap Ming. My colleague has given the link to the AI courses in the chat group and also the courses of data science in the chat group. Okay, any other further questions? Okay, so if there's no further questions, right, then we will close this session. Okay, thank you so much for attending this session. Thank you.